Hi everyone, Mary here, and we are going to do together a problem about a diver. So we have an open water scuba diver diving at a depth of 40 meters, and we want to know what is the total pressure on our diver. So here is the water, and our little diver is, let's put some goggles on our little diver and a little air tank on the back, is 40 meters below the surface of the water, and we want to know what is the pressure on our diver. So we're going to use the equation for determining the pressure depending upon the depth in the column of fluid. So that is going to be the density times the height times the acceleration of gravity. So the pressure on our diver is going to be the density of water. So we're going to start with fresh water. Fresh water has a density of 1 times 10 to the third kilograms per cubic meter. Our diver is 40 meters down, and the acceleration of gravity is 9.8 meters per second squared. So when we do the math, that is going to end up being a pressure of 392,000 pascals. That's 392,000 pascals. Now that is the pressure caused by the water, but he's on planet Earth, and so the air is actually pushing down at our diver with 1 additional atmosphere. So add to that 1 atmosphere of pressure. And we've got 2 weird units here kind of mixing it up. So let's get it all in one kind of unit. And the kind of unit we're going to use is, let's do it all in atmospheres. 392,000 pascals. We are going to get rid of pascals and keep atmospheres. 1 atmosphere is 101,325 pascals. And when we do the math, that's 3.87 atmospheres, plus the 1 atmosphere having to do with the air above the water. So the total pressure on the diver is 4.87 times the normal atmospheric pressure, or 4 times 87 atmospheres. All right, now that's the first part of the problem. The second part of the problem says, if the diver was in salt water, would the pressure on him be more or less? So let's think this through a little bit. This is our equation. The pressure is dependent upon the height, so that's not going to change with salt water. Acceleration of gravity is not going to change. So the thing that's going to vary with salt water is going to be density. What do you think is going to be bigger in salt water? Is density going to be bigger in salt water, or is density going to be less? Well, average density of salt water is 1.02 times 10 to 5 times 10 to the third kilograms per cubic meter. And the question's not asking us what the pressure on him would be if he was in salt water. The question is, will it be more or less? Well, if you go through this whole calculation, and if pressure here is greater, that means the pressure here is going to be greater. That means the total pressure on him will be more. So because of the increased density of salt water, increased pressure on our diver. So that will do for this one. See you next time.